And we're back. Our next team here for check-in, it's Team 2337, the EngiNERDs from Grand Blanc, Michigan. Guys, welcome to the show. Glad to see that we're in your shop.
How's it going?
Very good. Happy Valentine's Day. Glad to see you guys are in your shop. You're not going to waste any time between coming on and coming off the show. Why don't you guys introduce yourselves for everybody?
My name is Quentin Bollinger. I'm one of the co-head mentors of Team 2337.
I'm Noah. I am the chassis selection leader for this team.
I'm Gus. I'm the head of communications and a senior programmer on the team.
Cool. All right, let's get into it, guys. So we're hitting the home stretch of the season. We know that you guys are building a practice bot. How are you guys doing as far as that's concerned? And how far ahead of your competition robot is your practice bot?
That's ahead is very funny. That's a funny statement. But go ahead, guys.
So with our practice bot, we tend to do everything on that first before we put it on CompBot, just because then we get to see the bugs and the issues of trying to mold all our different prototypes together and our designs that we have. And we've actually already come up with a few issues so far, so it's good that we have practice bot ahead of schedule.
Cool. What kind of issues did you guys run into?
Just
So, I mean, some of our issues that, not issues, it's just working out the bugs, right?
Right.
So our gear mechanism, climber, stuff like that, we noticed some kind of, like I said, when you try things with bumpers on or not having bumpers on, or you have a loose prototype, and then when you finally make it in its final form, it's a lot tighter and things didn't work like they used to. So we had to make a couple changes there. But we also have the competition robot, powder coated and assembled. Noah here is one of the ones that assembled it, so you can probably talk about how that went.
Sweet.
Using the practice bot as the base design, assembling the chassis for the competition bot was pretty simple, or fairly simple this year. And
yeah, it went pretty smooth. Like I said, we used the off-the-shelf chassis in a day. Was the chassis we're using for this season. Saw a lot of it in the video that we showed earlier.
Nice. Very cool. All right. So, are you at the point where you guys are testing your code on the practice bot, or is it still like touches of mechanicals here and there?
So we finally have some actual time with the practice bot now. There's been a lot of it just mechanical grabbing onto it and putting different stuff, pneumatics and stuff like that. So finally we can work on something that's more solid. Actually, right now they're working on Auton code. So they're hard at work there.
We were able, I think it was last night or the night before, to run our one gear Auton, where we just drive forward, score on the peg. As you saw last week, we have the real lift mechanism, so we're doing that all autonomously on practice bot.
Wow, that's awesome. I'm only asking because I know you guys have a real gear mechanism, a gear lift on your airship. Are you guys having your pilot also practice scoring it within the period of time as well, or just more focused on the code right now?
We haven't figured out who's going to be our pilot just yet, but we've had some students up there when we're practicing, when we're doing gear cycles. We've had a couple different people up there just simulating and seeing what it's like, what standing position. Do you want to crouch? Do you want to be on one knee? Do you want to sit down? That kind of stuff.
Okay, cool. That's awesome.
Usually autonomous just grab somebody and just throw them up on the airship and have them pull the string a few times. So, yeah.
All right, there you go. Well, if you're gonna throw them up there, make sure they go down the ladder backwards. No want to go forwards. That's for sure. All right, cool. So let's talk about your climber. We know you guys mentioned you found some problems with it, and we see that you've got the word caution over here on the topic. What's that all about?
So I think our team is about 35 to 40% females.
Oh, great.
Some of our pit crew that actually work on the robot mechanical are females. Some of them have some long hair. So we're using some Velcro. So hair and Velcro don't mix real well. So you got to be careful. It wasn't running. No one was hurt. But they were actually leaning over to work on the robot, and their hair actually touched the Velcro, and we had to help them get it out of it. And it's like, we might want to actually make a cover, a cloth cover for the Velcro, so that when we're actually transporting, no one's hair gets stuck in the robot.
Wow. See, I never would have thought of that. That people hair gets caught in Velcro. Oh my gosh! Wow, that's rough. So beyond the hair grabbingness of the Velcro, how was the rest of the climber coming? I know you mentioned you were doing some bits on the practice robot with it.
Yeah, I mean, if one of you guys want to talk about what we did, it's nothing fancy.
Yeah.
Sorry, I didn't hear that quite well.
The climber. Talk about the climber, of how it went, and what we're doing.
Yeah, we did finish the climber on the practice chassis and tested it a few times going up and down.
Yeah,
I think times going up and down.
Right now we're not pushing the limit of speed of climber. I think the good example that we're trying to do is actually just make sure it's reliable. When we go to one of our first events, we don't want to. The example that we give was a 2011 mini box. At your first event, if your thing just went up consistently, that's all that mattered. You didn't have to have a under 1 second mini at your first event, right? So we look for the long haul. So we're trying to make sure that it's slow, consistent, reliable, nothing crazy happens, nothing damages the robot or the climb itself for our first event, but we have the capability to speed that up as the season goes on. So I think right now we're at about 5 seconds, I want to say, for our climb. 5
seconds is still a pretty good time, you know. I mean, I think you'll see a lot of teams. Yeah, oh yeah, you can definitely go faster, but I think you'll see a lot of teams. Their final climber will be at about 5 seconds, so I think you guys are in a great spot. That's really good to hear. Cool. So let's talk about a little bit more about the code stuff going on and how you guys are using your development bot to further the programming.
So our development bot, it's not like a version of our practice bot. It's just a bot that we can use that's reliable, that has encoders on it and gyros. And we work on a lot of different unique things. One of the things would be motion profiling, which has been very interesting to use. Just driving with encoders for auton, gyro, seeing like how different things work. It's very useful for especially newer programmers to learn on the robot and stuff like that.
Okay, cool. So it's not a practice robot. It's not really a third robot of your 2017 competition robot. But what is it? Is it just a kit bot or some other old robot or something?
Oh,
yeah, we did assemble a chassis to test code early just to see for movement. However, we have our practice robot is basically a pre-finalized version of our competition robot.
Okay, cool. And so the dev bot is like, what's the dev bot made of then?
I'm not.
It's a piece of plywood with some speed controllers and old chassis and kind of like a mix of everything, like sensors and all kinds of stuff.
It's a Frankenstein.
It's it's another Robo Rio for programmers to test with.
Yeah. Okay. So it's just kind of like anybody could do this, just with whatever leftover stuff they have to just play with. Cool.
Yep.
All right. Awesome. So now that you're with this dev bot, what stuff have you guys learned that you're applying in your new robot? I know that you're starting to get time with the practice robots. Your program attention is probably going to get focused there. But what have you learned so far with this other robot that you've had free reign with?
With what we've learned so far, just
I mean, the best thing to say, I think our dev bot is basically like our beta. So if we want to come up with a routine for the robot, you got to make the little lights flash on the dev bot before we push it over to the practice bot. So it's not like we're doing a lot of hard, coding on it. It's a matter of hey, we need subsystem F to work in this way when you click this button, and then when you click that button. So they just kind of simulate that on the beta one before hooking actual motors up that might go the wrong direction on the climber and cause bad things to happen. Okay,
that makes a lot of sense. That's a good practice. I wish more big companies would do something like that, but that's a different story. So last thing we're going to talk about your guys' machining process. But first, I want to remind everybody watching, if you guys have questions for the EngiNERDs, send them to us. Just hit !Q followed by your question in Twitch chat, and the chat will automatically pull it in and send it to us. And if we like it, we'll ask these guys live on air. So EngiNERDs, we see that you're in your shop. We see you've got a lot of really cool tools. I kind of wish that I was actually there to look at it all. Why don't you tell us a little bit about how that whole process goes for your team?
Yeah, real quick, I'll talk first about some of the machines that we have access to. You can see behind us we have two NC mills. So that lets us actually do bolt patterns, bore interpolations, that kind of stuff. So it's not a full CNC, but allows us to do some kind of tricky things. We also have two NC mills, or not mills, sorry, lathes behind us as well. That's for the most part the machines at our build facility here lets us use. They have a lot of other machines, CNCs, wire EDMs here, but mainly the team uses those two machines behind us. So in terms of the design process, I don't know if one of you guys want to kind of explain how we kind of walk, through design to working drawing, that type of stuff.
Usually it starts with a concept that we come up with, and then it'll go into a CAD stage where they experiment and with a drawing. And once we decide that the CAD should work with either wooden prototypes first, or others will go into a more metal-based prototype where we can use the machines.
Yeah, so like I said, first one, very crude, just get some information out. Then we start making off-the-shelf, using Vex Pro, VersaFrame, that kind of stuff. And then slowly refine more and more to where we have CAD. And we actually have, like, some drawings, if you will, here. I don't know where the good drawing went. I don't know where the good one went. Anyways, there it is. So we actually have, we'll kind of show it up to the screen. We make a working drawing for every kind of system with our little nerd face and everything. We also, like I said, for cutting parts, what size we need to cut them, what's it come from, that kind of stuff. So we do 100% CAD on a robot. Basically, before any machining can be done, they got to have a working drawing of that.
Nice.
Then it gets sent down to these guys here behind us. Noah's one of the ones that was helping do some machining, where they can actually type in the numbers, move the mill to the right location, and actually make the part.
So
if the print's wrong, if the print's wrong, they have to go change it before we'll make the part.
Okay. So if you have a working drawing, that does not mean something written on a napkin, right? I assume it means a real, actual dimension drawing.
Yes. Okay. The napkin sketches usually come from the mentors to say, hey, go make these changes or make this part upstairs so we can actually machine it. So.
Awesome. Cool. Well, that's really great.
A lot of times the other feature we use a lot with the machines behind us is we use hole tables. So instead of having the dimensional prints to each one of the holes, we just give the XY location to those holes, and we can actually enter them on the machines. I don't know if you've done that, so if you want to talk about that.
Like, you will have a row of holes or whatever. We can put a program in there based off of the change in the X or the Y. If it's a box, we can do both X and Y with a number of holes, and the whole table makes it a lot easier than reading all of the dimensions if they're individually done.
Yeah, nice. You just enter, hit go, and it moves another inch, and then drill another hole, move an inch. That's what you kind of saw in our video, where they were actually drilling and hitting the button to move it to the next one.
Very cool. Those kind of machines are, I find them super duper handy. I loved using them back when I had one in high school because it's a lot of times, especially with these robots, if you have rollers or stuff, there's a lot of parts that you make over and over again. So having the quick and easy sort of let the machine do the work for you is really, really handy. So, all right, so we're getting into the last day. Right before we leave, I want to just ask you guys, you guys are on schedule, you're on track. How do you guys feel about getting everything ready for bag? Thumbs up, thumbs down, thumbs down?
I want to say probably the on schedule, on track. I don't know if that's a true statement. To be totally honest with you, I think we could use, like everyone, I think you could use an extra week. We're still trying to hammer out a few things with our shooter and feed system. But I mean, right now we're able to intake balls, score gears, climb. We can do that all with the practice bot. Probably by, my guess is Saturday morning, we'll be able to do that all on competition bot. So this weekend's all about finally putting the shooter into the robot and hopefully start putting some balls up in that boiler.
Cool. All right. Well, we're looking forward to it. We can't wait to see what your robot looks like next week. It's only a few more days, so good luck to you in your last few days, and get back to work in a few seconds. So our next team on for check-in, it's going to be Team Spectrum, Team 3847. They're from Houston. We're going to bring them on after a very quick break But for now, EngiNERDs, thank you once again for joining us this evening here on Check-In.
Thanks, man. Thanks for having us.